Hello viewers, I am Kausalya. Today we are going to solve problem number 12 and 13. So here comes the problem. Find the value of R and the current flowing through it in the circuit shown when the current in the branch OA is 0. So this is the given circuit diagram, and in this circuit diagram we are asked to calculate the value of R and as well as the current flowing through this R when the current flowing through this branch OA is 0. Right. So here the first step is we are going to redraw the given circuit diagram. So when you redraw the circuit, you see this is how the circuit is. That is, you just keep this O as a main point here, right? So first draw OA, OB and OC. So from O to A, we are having a resistance value whose value is not given. We are simply having a resistor here. And from, you see, O to B there is a 4 ohm. So here O to B there is 4 ohm. And O to C there is a resistance R. And here also from O to C there is a resistance R. Right. Then from B to A there is 1 ohm. So B to A there is 1 ohm. And from C to A it is 1.5. So here it is 1.5. Right, and between B and C, as usual, we are having a voltage source and a 2 ohm resistor here. Right, so we have drawn the circuit. So from the circuit, you see it is clear that this is a bridge circuit, and since no current flow through this part, what does it means? That the bridge is in stable condition. Right, so under stable condition, what is the main thing to be noted here is product of resistances of opposite arms are equal. That is, product of the resistances of opposite arms, right? These two are the opposite arms and these two are the opposite arms. They are equal. So 1 into R is equal to 4 into 1.5. So that gives the value of resistance which is equal to 6 ohms here. Right, to find the value of resistance, you should know this concept that under stable condition, the product of resistances of the opposite arms are equal. Right, now one part of the problem is over. Now we need to calculate the value of current that flows through the resistance R. So here, as they had told, right, the current flowing through this part OA is 0. So now in this diagram we are removing that resistance, right, and the value of the resistance is not given, and though the value is given, if the current flowing through that part is 0, it is not going to create any impact, right? Therefore here the resistor R is totally removed. And here we are assuming the total current supplied by this voltage source is I, and this I gets divided into I1 and I2 like this, right? Now can you tell me the reason why this I2 is not get divided anymore here? Because you see at this node there is only one resistance which is connected. Therefore the same I2 flows through this 1.5 ohm resistor, and here also the same current I1 flows through this 4 ohm as well as through this 6 ohm also. Right. So again in the return path we will be having the same I that flows downwards. Right. Now we are going to calculate the total resistance of the circuit. Then only it is easy for us to calculate what is the value of I. Once we know the value of I, then we can easily calculate the value of I1 and I2. Right. Now here our main aim is we have to calculate the current that flows through this resistance R. Right. So through this resistance, what is the current that flows? It is nothing but the current I1. Right. So here we start up with the first step of finding the total resistance of the circuit. So here in this case, from this diagram it is clear, right? You see these two resistors are in series, and again these two resistors are in series. So how to find the total resistance? Just simply we have to add. That is 1 plus 1.5, that gives 2.5, and 4 plus 6 gives a value of 10 ohms. Right. So this is what it is done here. Right. Now we are again redrawing the circuit. Right. So while redrawing the circuit, you just don't consider this 2.5 amps. This is the final value which I had found. Right. So here we are having, you see, these two resistors are combined together and these two resistors are combined together. And again you see the nodes here are, here it is B and here it is C. Right. So here the total resistance is 2.5 and here it is 10. Therefore, just draw the diagram. Here it is 2.5 and here it is 10. Right. Now, we have to calculate the total resistance. So, how to find the total resistance here? Here these two resistors are connected in parallel. Right. So, what is the formula? So, here the formula is R1 into R2 divided by R1 plus R2. So, just substitute the values accordingly and finally the total value of the resistance is 2 ohms here. Right. So, now again I am going to redraw the circuit. That is, you see, the entire value of these 4 resistors is now reduced to 2 ohms. Right. So, between B and C, I am having a 2 ohm resistance. That's it. So, again when I redraw the circuit, this is B and this is C. Right. I am having a 2 ohm resistance, and apart from that, we are having between B and C, I am having a 10 volt with a 2 ohms. So, this is what drawn here. Right. Now, we can easily calculate the total current that flows in the circuit. Yes? Right. So, here total resistance is 2 plus 2, 4 ohms, and here the total supply voltage is 10 volt. Therefore, 10 by 4 gives you a value of 2.5 amps. Right. This is the total value of current. So, that is why here I have mentioned it as 2.5 amps. Right. And now we need to calculate I1, because I1 is the current that flows through 6 ohm resistor. So, here this 10 ohm is nothing but it is a combination of 4 ohm and 6 ohm here. Right. So, I need to calculate I1. So, how to calculate I1? By using the current division formula. So, current division formula is nothing but total current into opposite resistance divided by sum of resistances. Right. So, here the total current is 2.5 into opposite resistance. So, the resistance which is opposite to this part is 2.5 ohms. So, 2.5 divided by the total resistance. Here simply you have to add 2.5 plus 10. Right. So, here you see, when you substitute the values here, and finally the value of I1 is 0.5 amps here. Right. So, this problem gets over here. We will proceed with the next problem. So, the problem number 13 is, in the circuit shown, determine the current through 2 ohm resistor and the total current delivered by the battery. Use Kirchoff's laws. So, here again you see, this is a bridge circuit, and we are asked to calculate the current that flows through this 2 ohm resistor and as well as the total current given by this battery. Right. So, here we are assuming currents by our own assumption. So, here I am assuming the current flowing through this closed path as I1 and this closed path as I2 and this closed path as I3. Right. Now, we are going to frame expressions, not expressions, in the form of matrix form. Right. So, by using Cramer's rule. So, what is the basic Ohm's law? It is nothing but V is equal to IR. Right. Now, I am going to write each and everything in the form of a matrix. So, here V is nothing but this is a voltage source here. Right. So, now assume this is our loop 1, this is our loop 2 and this is our loop 3. Loop 1 has no voltage source. Right. So, it is 0. Again, loop 2 has no voltage source. So, it is 0. Whereas loop 3 has a voltage source, it is of 10 volt, because you see the assumed current direction is like this. That is, current flows in this way from minus to plus. Therefore, the supply voltage is plus 10 volt. So, this is what it is mentioned here. Right. The next thing is, write the current flowing through each loops. They are I1, I2 and I3. And the next thing is, we are going to calculate the value of total resistance R here. Right. So, writing this matrix is very, very important. So, you have to do this part very carefully. So, here the first thing is, you see, the diagonal elements are nothing but the sum of the resistors present in that particular loop. For example, consider loop 1. So, this loop 1 has 3 resistors, 5, 4 and 2. Right. So, 5 plus 4 is 9 and 9 plus 2 is 11. Therefore, the summation of resistance is 11 here. Again, when you consider Your second loop, again it has 3 resistors. So 3 plus 2 plus 1. So that gives a value of 6 ohms. So I had written here. And next we are considering this loop as a third loop. So again this has 3 resistors, 5 and 3 and 1. So that gives an answer of 9 ohms here. Right. Now the next thing is, you see, even you can write like this, it will be easy for you. So the next thing is, here we have to write the resistor value which is common between your loop 1 and 2. 1 and 2 here, right? So this is your loop 1, this is your loop 2. What is the resistor that remains common? It is 2 ohms here, right? Since the value of this, the current direction remains the same. You see, I1 flows through 2 ohm like this, and similarly I2 also flows through this 2 ohm in the same manner. Therefore, the value of the resistance is simply 2. Again, when you consider the resistor which is common between your first loop and third loop here. So this is your first loop and this is your third loop. So what is the resistor that remains common? That is 5 ohms. Right, that is I1 flows through this 5 ohms in this way, whereas I3 flows in this way. That is, they are opposite. Therefore, here minus 5 is written. Am I making sense here? 5 ohm is common for this loop 1 and loop 3. Since the direction of current flowing through the 5 ohm, that is I1 and I3 are in opposite directions. You see, I1 flows like this, whereas I3 flows in opposite way. Therefore, here a minus 5 is written. Right. The next thing is, now we had finished this one, we had written this part. Again, the same value holds here. Right, 2 here minus 5. Now we have to find the elements which is common between second loop and third loop. You see 2, 3. This space has to be filled. So what is the value of resistor that is common between loop 2 and loop 3? So this is loop 2 and this is loop 3. You see here the current. What is the common resistor? 3 ohm is the common resistor. Here you see the current flows through this 3 ohm like this, and again this I3 also flows in the same way like this, right? Therefore the value of resistance is simply 3 ohms, right? Now the next thing is, we are going to calculate the determinant value. That is, this is known as del. You see, determinant value of the resistors. So again, this is a max thing. I hope you people know how to solve this determinant. Let me explain anyway. That is, you see, first 11 is written here, right? Then you have to remove this column and this row, and you have to multiply like this. 6 into 9 minus of 3 into 3. That is what written here. And to this element, we have to insert a minus sign here. So minus 2. Again, you have to leave this column and this row. So the remaining terms will be 2 into 9 minus of minus 5 into 3. That is what written here. And finally, you see here it is minus 5. And for this minus 5, 2 into 3 minus of minus 5 into 6. Right. So this is the way to write an expression. So again, you simply solve these values, and finally here we are ending up with 249 as the answer. Right. So this is your value of del here. Next we are going to calculate the value of del 1. Right. So for del 1, you have to remove this first column and you have to replace that values with the voltage values. Wait, let me show. So this is your value of del, right? If you need to calculate del 1, you have to replace this first column with this voltage value. That is 0, 0, 10 should be written in the place of this column, right? So this is what which is written here, 0, 0, 10, and the remaining things they remain the same, right? So again, when you solve this determinant value, you see 0. So since it is 0, the final value will be 0, right? So simply 0 here, and here minus 2, you leave this column, okay? This column under respective row here. So what happens? 0 into 9 minus 10 into 3. So minus 30 here, and again minus 5. So 0 into 3 is 0. So minus of 10 into 6 is minus 60. Right, again when you solve, the final answer is 360. Similarly for del 2, the second column is replaced with the voltage source 0, 0, 10, and the remaining 1 and 3 columns remains the same. Again when you solve, you see 11 into 0 into 9 is 0, so minus 10 into 3 is minus 30. The next thing is 0, so anyway it will be 0, so simply write it as 0. And the next number is minus 5 here, so minus 5, 2 into 10 minus 0, so here it is 20. Again when you solve, the final answer is minus 430. And regarding del 3, again the first and second column remains the same, and the third column is replaced with the voltage source here. So again when you rewrite the things, here the final value of del 3 is calculated as 620. Right. Now we are going to calculate the values of I1, I2 and I3. Here the formula is I1 is given by del 1 by del. Therefore here it is 1.4457, and I2 is del 2 by del, and I3 is del 3 by del. Right. Just calculate all the values here. The next thing is, we need to calculate the current that flows through this 2 ohm resistor. Right. So what is the current that flows through this 2 ohm resistor? From this diagram, we are having I1 and I2 flows through this 2 ohm. Right. And again, since the direction are same, so the current flowing through this 2 ohm resistor is I1 plus I2. Can you get what I am saying? The current, this 2 ohm is common for loop 1 and loop 2. Right. Therefore, two currents flow through this 2 ohm resistor. And again, the currents are flowing in the same direction. You see, I1 also flows in this way, and again I2 also flows in the same way. Therefore, the current flowing through this 2 ohm resistor is nothing but I1 plus I2. Right. So this is I1 and this is I2. So here the answer is minus 0.2812 amps. So here what is the thing that minus denotes? This minus sign denotes that the direction of this current is opposite to the direction we assumed, because in this diagram we are assuming the current direction by ourselves. Right, it is not mentioned anywhere. So here we had I had assumed the current direction like this. Even you can assume current direction like this also. Okay, nothing is wrong. Anyway, the final answer is going to be correct. So here the negative current indicates that the direction of the current we assumed is opposite, is to be in the opposite direction. That is what indicated by this minus sign. If the direction assumed by ourselves is right, then it will be simply 0.2812 amps, but here it is minus 0.2812 amps. This shows that the direction of current assumed by us is wrong. It should be in this way. Right. Other than everything is fine. Okay, no need to change the direction, nothing. Okay, once if the answer is correct, then it is okay. And the next thing is total current delivered by the battery. So here in this diagram, right, what is the current delivered by the battery? The current that is delivered by this battery is I3, right, because I3 is the current that flows through this part. So we had already calculated I3. Therefore, the value of I3 is 2.489 amps here. Right. So here comes the end of this problem. If you have any doubt, let me know in the comment section. Thank you.